For example, the figures below show that to find the reference number t, it's helpful to know the quadrant in which the terminal point determined by t lies. If the terminal point lies in quadrants 1 or 4, where x is positive, we find t by moving along the circle to the positive x-axis. If it lies in quadrants 2 or 3, where x is negative, we find t by moving along the circle to the negative x-axis. The reference number t is always between 0 and pi over 2, equals 0 is smaller than t, which is smaller than pi over 2. Terminal points on the unit circle. Suppose t is a real number. Let's mark off a distance t along the unit circle, starting at the point 1, 0, and moving in a counterclockwise direction if t is positive, or in a clockwise direction if t is negative. In this way we arrive at a point p parenthesis x, y on the unit circle. The point p parenthesis x, y obtained in this way is called the terminal point, determined by the real number t. Reference number. Let t be a real number. The reference number t associated with t is the shortest distance along the unit circle between the terminal point determined by t and the axis x.
Here we can see the values of sine and cosine for the reference value in the unit circle. For example, 0 equals to 0 degrees. In sine is root square of 0 over 2 is equal to 0 over 2 is equal to 0. Another example would be pi over 4 equals 45. In sines, the square root of 2 divided by 2 is equal to 1 divided by square root of 2. And the cosine is square root of 2 divided by 2 equal to 1 divided by square root of 2. These are the reference value for the unit circle and how it is represented with the radians and the angles in the sine and the cosine. By the other hand, if we want to obtain the value of the sixth trigonometric function using reference values in the unit circle for an angle in radians smaller, we have to first find the reference angle. For example, if we have an angle of minus 150, we go clockwise and count 150 and then count the reference angle. That means what's missing to get to 180, so that's 30. If we get 30, we can make a triangle, a right triangle, and the opposite side, the opposite side of the triangle according to the angle 30 will be minus 1. The adjacent will be minus square root of 3, and the hypotenuse will be 2, because this is how the unit circle function its measurements. For example, if we want to find the sine of minus 150, we have to do it minus 1 over 2. This means it is minus the opposite divided by the adjacent. Also, if we want to write, for example, the second, it will be equal to minus 2 over square root of 3, and so on. You can use the acronym called SOHCAHTOA. It's very easy to use and it's very useful.
How to obtain the value of the six trigonometric functions using reference values in a unit circle for a negative angle in radians smaller than 2p. Well, if you have a negative angle measure and you want all the functions moving a full rotation 2p, basically it's the same since the only difference is that it's moving clockwise, making the angle value negative. Where it ends, find the reference values either by using the chart or by observing in a unit circle, and with that values find coseno and seno, and that will allow you to find the rest of the trigonometric functions since you'll have the basic values, which are x and y. And how to obtain the value of the six trigonometric functions using the reference values in the unit circle for an angle in radians greater than 2p. Well, if the angle is greater than 2p, you will have to preferably convert to degrees. Divide that value by 360, and the decimal points that go after your whole number, multiply those by 360. This way you will know in what sector it ends, and with that information you will have the signs for the coseno and seno that will allow you to find the remaining trigonometric functions.